day. Welcome back to Math Capsule by HannahE. We're going to be working on a lesson on exponents today. Let's see how this goes. All right. So we have lessons on exponents. Okay.
I need to go outside.
Hold on one moment. I'm just doing a video, okay? You have to be quiet in my video. Yes, ma'am. Yes, ma'am. Okay. See, yes, ma'am.
I need to go potty first.
Do you understand you have to be quiet?
Yeah.
Yes, ma'am. Sorry about that. Excuse my 3-year-old. Okay, here we go. So we have lessons on exponents. So most of you have learned your multiplication tables. So first thing that I like to teach students about is something called squares. So we have squares, and squares is the concept of multiplying a single number by itself. So you've actually learned these already if you know your multiplication tables. They just probably weren't explained as if they were squares. So let's look at a few of them real quick. We have 1 times 1 equals 1.
Here, Mommy.
2 times 2 equals 4. Thank you, sweetheart. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. 6 times 6 equals 36. 7 times 7 equals 49. 8 times 8 equals 64. Now I want to switch to a different type of notation, and it means the same thing. But we will have 9 times 9, which will be 81. We have 10 times 10, which is 100. And we have 11 times 11, which is 121. Then we have 12 times 12, which would be 144. And then we'll have, let's switch notations again here. And let me get my handy dandy calculator to help us make sure I don't mess any of these up. It's been a little while. Faith, remember you have to be quiet, okay? All right, so the other way that this could be written is 13 squared. That means the same thing as what we have been doing. It's 13 times 13, which would be 169. And you have 14 squared, which would be 196. If I did 15 squared, should be 225. 16 squared, 256. 17 squared should be 289.
Help me. I found a room outside.
18 squared, 324. 19 squared, I guess it's going to be 361. Yes. 20 squared equals 400. And then 25 squared is a common one that gets used, which is 625. One moment.
I found a really puppy for her. It's so cute.
Go outside.
Come on. Let's go put that blanket
Okay.
down.
At this point in the video, I would like for you to pause it and copy these down if you don't already have these, because if you can memorize these, that will make your life a lot easier as we move through this lesson. Okay. All right, we're going to take a moment and we're going to look at this from the opposite extreme. So we just learned that squares are multiplying a single number by itself. Now when we look at powers of a number, let's look at that real quick. Then we take a number and multiply it by itself however many times the power says. So we're going to look at how that works in just a moment. Okay, so let's look at an example of this. I'm going to adjust my camera just a little bit because I want to use a little piece of that board there. Okay, so the first example I'm going to give you will be 3 to the third power. This is the same as saying 3 times 3 times 3, which is equal to 27. Okay, now let's look at another example of this. All right, so let's say we have 2 to the 5th power. This is the same as saying 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. So whatever this power is, that's how many 2's we're going to write, and then we multiply them. So my quick way of doing this without a calculator is like this. Bring that 2 down. You have 16 times 2. So that should be 32. Okay. Now, if you have a calculator, I have the handy dandy TI-84 Plus. So for this one, all I have to do is type in a 2. I don't know if you can see that on the screen. And I'm going to hit my raise button, power 5, and then I'm going to hit my enter, and it gives me 32 as my answer. Now, most calculators have some form of that, and sometimes it looks like the YX button like that. So you put in the first number, then you hit this button, and then you put in the second number, and it'll give you the power. All right. So, on the opposite side of powers, we have something called roots. So, let's see what that means. So, if you remember that list that we just made, when we're dealing with the roots, what we do is we look at the answer first and we work backwards. So, we're going to start with something called a square root, and then we're going to look at other types of roots. Okay? So, square root asks what number times itself will give me the number under the root sign. Okay. Now, let's take a look at that. So, say we have some random number given to us. Say the number 49. So if we look at our list that we were given, a list that we compiled a moment ago, you'll see a list of squares, and then on this answer side, you see the answer. So what you're doing is you're looking at your actual answers on that list and find the one that has 49. So if it has 49, that's the same as saying, what is the square root of 7 times 7? So for square roots, we only write one number though. So the root of this is 7. Okay, let's do one more. And then we're going to look at a little bit more complicated version of this. So for square roots, it's very simple. Let's say we have the square root of 625. When we look at our list, we will notice that we have an answer. We find the one that has the answer 625, and it's the same as saying 25 times 25, and our answer is a single number. So that's where students sometimes get a little bit tricked up on these, is they want to write two numbers. That's not accurate. We only write one number for the root. Okay? And you see all of that. Make sure you can see all of that. Okay. So now we're going to look at a different type of root. Okay? So it still uses the same concept, but it gets a little tiny bit more complicated. Okay, now almost every calculator does have that square root symbol. So now on my calculator, and I think actually on the TI-30 it's the same way, you hit the second button and then you hit the button that says x squared, and you're going to type in, let's make sure I hit the right thing. Yeah, there we go. I may have hit the wrong one the first time. And let's put in, say, 64. And then you hit your enter key, and it gives you 8. And I think on the TI-32, it's the same way. You have to hit the second button and then your x squared button, and then it gives you the square root. And then you type in the number, and it gives you the square root of that particular square. Okay? So, now, let's look at a different type of root. Okay? So these are sometimes more easily explained if we just use examples. So we're going to call this example A. Let's say we have the cube root of 125. So now the question is, what number times itself 3 different times will give me 125? Well, one thing that I like to do is I don't make students memorize the list of cubes. Maybe the first few they do memorize, but I don't usually make them memorize the whole list of cubes. But you can put that into your calculator and find it that way as well. On this one, let me see. Whoa. I know on the TI-83 above the YX button it has it. Oh, it's been too long, this one. One way to try this is you could, which would take time, but you could do 1 times 1 times 1, which gives you 1, 2 times 2 times 2, which gives you 8, 3 times 3 times 3, which gives you 27, 4 times 4 times 4. One moment, please. Are you serious right now? I am in the middle of doing a video. Stop interrupting me. No. Shh. All right, so So then you have 64. Then you have 5 times 5 times 5, which would be 125. So in this case, this is the one I'm looking for. So my final answer is always a single digit for my roots, and it is a 5. Okay? So, you can get to the answer if you work your way through the numbers. And if you have a calculator, I'll have to show you how to get to it on the calculator. I'm trying to remember how to do it on this one. I know there's a way. I don't know what it is. I'm going to have to look that up later. Oh, might be under that. Oh, wow, that's cool. Oops. I'm not sure on this one. That's weird. This one's set up a little bit differently. All right, we'll figure that out later. Okay. So, I do want to show a concept that is a little bit more tricky, I guess, to kind of work through and kind of give you a strategy for how to do it when you're dealing with numbers that are not perfect cubes or perfect squares, etc. Okay, so we're going to call this one example B, and let's say we have the fourth root of 256. Okay, so we need a number that when multiplied by itself 4 times, we get 256. Okay, so this is the set that we need. So our final answer is always only a single digit. So the fourth root of 256 is the number 4. Okay? So now we're going to look at one other concept and learn something a little bit cool on this. All right. Let's say we have, I'm trying to think if I need to teach that. Let me think. All right, let's look at breaking down roots that aren't perfect squares. Squares, cubes, or fourths, etc. Okay. All right, so let's say we have the number. Let's say we have the number. Take the square root of 128. Okay, so what I do is I teach students. This is why it's so important to memorize your squares. Okay. So what you do is you're going to look at your squares list, and you'll quickly determine that there's no number 128 in the answers anywhere. Okay, so the next step is to say, what perfect square can I divide evenly into 128? So when I look down that list, let's say I started at like 256. That's too big, right? So that's not going to work. So let's say we go to 12 times 12, which is 144. That is too big still. So we need something smaller than that. So the next one up is 121. That's still pretty close to this. But it has to divide into this without leaving a remainder. So I'm going to go a little smaller. And 81 is still pretty close. So let's try 64 and see what happens. So using my handy dandy calculator, I take 128 and I divide it by 64. Now, you're always dividing by the answer of your squares. And I'm going to show you why in just a second. So, the square root of 128 is the same as saying the square root of 64 times 2. 64 will go evenly into 128. So now what I will do is I will split this into two parts. So I have the square root of 64, and then I have the square root of 2. Well, square root of 2 is a prime number, so it will not break down any further. But I can break the 64 down to 8. So what I do is I write this as 8 on the outside, and I leave this square root of 2 part underneath the square root sign, and this is my answer. So the square root of 128 works out to be 8 times the square root of 2. Okay?
We saw B.
All right. Now, let's try this in a different problem. Let's say we had we're going to do the square root of 432. Okay? Now, if you look at your squares, you'll see that 20 times 20 is 400, and then if you did 21 times 21, it will be bigger than 400. So, but none of them gives you 432. So 400 is too close to it. So we need to move back up the answers until we find one that we think will go into this. Okay. So anything in the 200s, you could start trying around to, like say 256. So let's try that. So 432 divided by 256. That leaves me with a remainder. If it gives you a decimal on your calculator, that means it has a remainder, which we do not want. So we need to go smaller than that. So let's say we tried 196. So 432 divided by 196 still leaves me with a remainder, so I need to go smaller. Okay, so maybe 144. Let's try that. 432 divided by 144. Now, there is a long, arduous method for how to get to this quickly, but if you follow this process that I'm teaching you, it makes things a little bit faster, in my opinion, than the long, arduous method to work this out. Okay, so I just look at the number that's under here. I look at my answers on my squares chart, and I determine which one is most likely to go into my answer underneath my root sign. So once I divide that, 432 is divisible by 144. So I have 144 times 3. Okay? So now what I do is I ask myself, what do I need to do here? So I will break this into two parts because I know the 144 is a perfect square. So sometimes inside of numbers, a perfect square can be hiding inside of a bigger number. So we have the square root of 144 times the square root of 3. Now 3 is a prime number. It's not going to break down any. But the 144 will break down to 12. So I put 12 and I leave this square root of 3 underneath the sign, and then that would be my answer. Okay? So that is how we do that.
What, Mommy?
All right.
Mommy?
Yes.
What's your wiping off?
The work that I did right there.
Oh.
Okay. Now there's something else we need to talk about. And that is multiplying and dividing exponents.
Mommy.
Oh, thank you, sweetie.
Yeah.
Okay.
Mommy?
Yes, love. You see, Mommy's doing her video, baby.
Mommy, can I do it?
And when you get a little bigger, you'll definitely be able to do it. Okay, so So let's say you have this as a problem.
1.
Let's say you have 2 to the 4th power times 2 to the 3rd power. All right, so the first thing we have to look at is the components of the exponent. So I did forget to go over this at first, so let's talk about this real quick. So this portion here is called our base. And this here, this number here is called your power. Okay? So remember that 2 raised to the 4th power is the same as saying 2 times 2 times 2 times 2. Please don't touch that. Thank you.
I was getting a paper for you.
Oh, I don't need any paper. All right, so that's what that's saying. Now, when we're multiplying exponents, the base has to be the same. Okay, you cannot multiply this if the base is not the same. So we leave the base the same, and we add the powers. So this becomes 7. Now let's see how that will work. So we know that this one will translate. Sweetheart. So we know that this one will translate to 2 times 2 times 2 times 2. And we know that this one will translate, and since it's multiplied, we can put a multiplication sign between it, times 2 times 2. All right, now, if we were to count all of these up, our base stayed 2, correct? Yes. Now we count them 1, 2, 3, 4, 5, 6, 7. So we have 7 there. So when we're multiplying, instead of having to write all this out every single time, we keep our base, we add the exponents. Okay? So let's write that out in words. When multiplying exponents, base must be the same. Add the powers. Okay? And you find Big Sissy?
Yeah, but there was bees outside. They
Okay.
scared me and helped.
Okay, so go find her and tell her to turn on your show for you, okay?
Okay.
Thank you.
Don't let bees in the house.
Yes, ma'am.
And let it open so the bees can get in the house.
Okay, yes, we don't want any bees in the house. All right, so very simple. The base has to be the same, and then you add the powers. So let's see what happens if we have one where the base is not the same. Let's say we have 4. We'll change that to example 2. And let's say we have 4 to the q power times 16 squared. Okay? Now, the way that this one is right here, we cannot multiply it without changing something. Something has to be changed here. So we can either change this and figure out what the number is and then multiply it and then work backwards. Or we can ask ourselves, does either one of these have a power that we can break this down into? So,
That was a panel.
okay. Hey, you have to go find your sister.
She's got to play with me outside.
Here, come on. Let's go watch on my thing. If the bees are getting us, let's watch outside, okay? Come on. Here, go in my room and turn on my TV. Toby! Oh! Okay, sorry about that. Okay, so here we are. Now, we could break down 16 into 4 squared. Okay, so we say 4 cubed here times the 16 can turn into 4 squared. Okay. Now, how do we know that? Well, 16, if we look at our square list, is equal to 4 times 4. All right? So, we take 4 cubed and leave it, times 4. 2 times 2 here is 4. Okay? So 4 to the 4th power should be the same as 16 squared. All right? So let's double check that and make sure. We have 4 times 4 times 4 times 4, which is right. So, yes, they do equal. Now what can we do? Well, we know our bases are the same. So we say 4 is our base. It stays the same. And then we have 3 plus 4 as our powers. So this becomes 4 to the 7th power. Okay? But our base has to be the same in order to work the problem because we can't combine bases that are different. All right? Now, all right, that's how we do that. Let's talk about what happens when we're dividing exponents. Now, the cool thing about this is we're learning about this with numbers, but this is also going to come back in handy when we look at algebra as well, which is kind of cool. Okay, so let's say we have 2 to the 8th power divided by 2 to the 4th power. Well, let's see what that means. So we have 2 times 2 times 2 times 2, 4, 5, 6, 7, 8. Double check yourself. 1, 2, 3, 4, 5, 6, 7, 8. Then we have 2 times 2 times 2 times 2. Now, if we remember in counseling, if we have the same number on the top and the bottom, we can cancel them. So cancel that set. This set will cancel. This set will cancel. And that set will cancel. So we're left with how many 2's? 1, 2, 3, 4. So we have 2 to the 4th power. Now, what do we do here? Is this the same thing as saying 2, 8 minus 4? 2 to the 4th power? Yes, it is. So, when we divide exponents, we're going to subtract the powers. So, when dividing exponents, bases must be the same. Then subtract powers. Okay. Let's go ahead and look at this using algebra. Okay. So let's say we had the following scenario. X to the 7th power divided by x to the 3rd power. So that's the same as saying x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. One more x needed. And then we have x times x times x. Now you do not have to write this out every single time. I'm writing it out just to demonstrate what's happening. How many x's are we left with? Well, let's count them up. 1, 2, 3, 4. So our final answer is x to the 4th power. Okay? So what could we have done instead? X, since our base is the same, 7 minus 3 is equal to x to the 4th power. We could do that quickly, and we could do that in our head. Okay? Now, the same concept works for multiplication as well. All right, let's look at this and see what happens when we have multiplication. And I'm going to make the multiplication one a little bit more complicated. Okay? So, let's say we have a cubed times b cubed multiplied by a to the 4th power, b to the 7th power. Okay? So, this is an algebraic look at the exact same concept. So, we take our a bases, we have two a's, and we say, and we can put them together. Now, I'm going to write out what's happening, but you do not have to do all of this, because I'm going to teach you what happens with this. Okay, so we have three a's here, right? Then we have a set of 4, and then because it's multiplied, we keep going. We have 3 b's, and then that's one set from right here, and then we have 7 b's in a row. 6, 7, barely squeezed it in there, okay? So now, looking at this way, how many a's do I have here? I have a to the 1, 2, 3, 4, 5, 6, 7th power, and then I have b, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 10th power, okay? Sure, that looks like a 10. So that's to the 10th power. Okay? So, what we could have done is looked at this and realized that we had a cubed, a to the 4th, b cubed, b to the 7th, and just added these exponents. So we have a to the 7th power, we have b to the 10th power. Okay? So, this works no matter which way you do this. Okay? Now, there is something we need to talk about called negative exponents. So let's say I have the number 2 raised to the negative 3 power. That's the same as saying 1 over 2, and when I move it to the bottom, it becomes positive. So that will be the same as saying 1 over 8 if I were to work that out. Okay? Now, the same concept works with algebra as well. So let's say we had y to the negative 4 power. This is the same as saying 1 over y4. Okay? Now, let's look at one other concept here. Let's say we had 1 over 3 raised to the negative 2 power. Now, if it starts with the 1 on top, we do the reciprocal. So this is the same as saying 3 squared over 1. We flip it over. Reciprocal means to flip a fraction over. So we flip it over, and now we have 3 squared on top, which is 9 divided by 1, which turns out to be just plain 9. Okay? Now, let's look at how that would look in algebra. Let's say we have 1 over, actually I'm going to use a variable here. Let's say we have a over b to the negative 2 power c4. Okay? When we're doing algebra, we don't want to have any negative exponents. So what we do is we take this b squared and we put it in the top. So this becomes ab squared. This c was already positive, so it's going to stay in the denominator and look like that. And that is how you would simplify that. Okay? So, I want to show one kind of complicated example of this using algebra and see how we use all of these skills together in one problem. Okay? So, let's say we had 2 raised to the 5th power over 2 to the 3rd power x to the negative 7 x to the positive 4, y8, y negative 2, z 4, z to the negative 5. Okay. So before we start simplifying anything on this problem, before we start to do anything, we need to move some stuff around so the negative powers are positive, okay? So our very first step is going to leave the numbers alone. So we'll leave that there. All right, I have an x with a negative 7, so that's going to drop to the bottom. So I have an x to the positive 4, and I'll put this x to the 7 on the bottom so it now becomes positive. Because remember, we have to flip it over. I had y to the positive 8 next. Now I'm going to check my y's. I have y with a negative 2, so that one needs to move up to the top because it was in the bottom initially. Okay? Then I have z with a positive 4. This z has a negative 5, so it needs to move to the top. So we'll move that to the top. Now that all of my powers are positive, I can continue to work this problem. Okay. So let's see what happens. So I have 2 to the 5th power over 2 to the 3rd power. Are these being divided? Yes, they are. So I can say 2 5th power minus 3rd power would be 2 squared. Whoops. 2 squared. Okay? Then I'm going to look at my y's. I have all my y's in the top, so that becomes y to the 10th power because I added these two exponents. I have both z's in the top and everything's positive, so that becomes z to the 9th power because I add 4 plus 5. Now my 2's have already been dealt with, so I should actually cross them out. Anything that you've already dealt with, cross out as you go. That way you don't get confused. Now we have just the x's on the bottom, and we have x to the 11th power. Okay? So, this is an example of something you would see in algebra using the same concepts of the exponents. All right, that concludes our lessons on exponents for now. I will put some links for homework on this at the underneath the description. All right, thank you.